Now, the data structures which are used by a file system will vary from file system to file system. For example, if you take the file system which is used by Unix UFS, it is going to use a different structure, and the file system used by, let's say, Windows, right, NTFS or FAT or EXT. So all these depending on the type of file system, each file system is going to use different data structures. And an operating system, if it is implementing that particular file system, then that operating system is going to implement the file system structures which are used by that file system, right? Therefore, we are not going to get into exact details about which file system is using what data types. Instead of that, we shall discuss about the general principles which will help you in implementing any file system. So whatever we are going to discuss here is the generic topic, and we are not going to get into any case study. Like, we will not be discussing in particular about Unix or in particular about Windows. So we just say a generic what is the generic way in which file system is going to be implemented. Okay, so in the previous video I told you that there is a master boot record which is going to have the partition table, which means the entire hard disk can be divided into various partitions, and in each partition we can have a separate operating system and a separate file system corresponding to that operating system, right? Now let's see within each partition what could be there. Okay, and again, when I'm saying about this within each partition, I'm not talking about any particular operating system. It could be any generic operating system. Okay, now let's see this. Several in-memory and on-disk structures are used to implement, so this word is implement, are used to implement a file system. So which means while implementing a file system, we are going to use various data structures. Some data structures are going to be in the memory, and some data structures are going to be in the hard disk, right? So whatever it is, they are going to be used. Okay, these structures vary depending on the operating system and the file system, right? But the general principles apply. So what I mean to say by this is, for example, Windows may use either FAT or NTFS or EXT. Now depending on what is the file system operating system is implementing, these structures are also going to change. But then we are not exactly talking about a particular operating system, and so we talk about only general concepts here. Okay, now the first one is block control, boot control block. So in the earlier video I have shown you that there is something called as boot control block. So in every partition or a volume, we are going to have one operating system, and whenever you start your computer, your BIOS is going to go to the MBR, that master boot record, and it is going to execute the code, and then out of this MBR is going to provide you about the partition table. From the partition table you are going to get into a partition, and now you are supposed to load the operating system code which is present in that partition. So in order to find out where that operating system code is, this block is going to be helpful. In every partition, the first block is going to contain boot control block. Now it will give you information about where the operating system code is present and how to load it, and what is the most important code you have to load into the memory in order to start with your operating system, right? Now see this, it contains information needed by the system to boot an operating system from that volume. So volume is also a partition. So every partition or volume is going to contain, you can assume that it is going to contain a separate operating system. It is not the case always, but if you can take, if you assume that every partition is going to contain a operating system, then the first block is called as boot control block. Now it will give you the information to load that particular operating system from the volume. Now this particular block is called with different names in different operating systems and file systems. In Unix file system, it is called as boot block. That boot control block is a generic name, and the specific name coming to the Unix is boot block. And in NTFS means new technology file system, it is called the partition boot sector. Got it? So the names are changing, but the concept is same. Anyway, all the operating systems are going to have, any operating system is going to have the first block dedicated, which is going to say where to load the operating system from, right? Otherwise, if an operating system is not going to have this block, it is supposed to leave out some space for further implementation. Every operating system is supposed to have this. And the next one is volume control block. See, main purpose of any file system is to keep track of which file is mapped to which blocks in the hard disk, right? And what are the free blocks. So all these information have to be stored by the file system. That is the main purpose of the file system. Therefore, this volume control block will know exactly about how many blocks are available in this partition to be allocated for the files, right? Now see this, it contains the volume details such as the number of blocks in the partition, size of each block. So this information will be maintained by the volume control block. So following this boot control block, the next block will be volume control block. In this volume control block, you will find out exactly how many blocks are there in the partition, right? And what is the size of each block. Depending on that, whenever you get a request for a file allocation, you will choose how many blocks to allocate and how many blocks are required, okay? And in the UFS, which means Unix file system, this one is called as the super block. So again, that is the generic name, volume control block, and the specific name coming to UFS is super block. And in NTFS, which means Windows file system, this information stored in master file table. The same information will be stored in something called as master file table, right? So after knowing about how to load the operating system and where the operating system is, and after finding out how many blocks are there, you need to keep track of how many blocks are empty, isn't it? So that you can know where to allocate which file. So let's see the next one. Now the next one is directory structure per file system. It is used to organize the files. So this is the block which is going to give you about everything about the files, how the files are organized. So what are the directories you have and under what directory you are going to have a file. The entire directory structure is going to be stored in this block. And the next one is called as file control block. It is going to give you all the details regarding a file. So for every file you are going to have something called as file control block, and in the file control block you are going to have all these details present, right? So what are all the details? See this, for every file you are going to maintain this. Now what are the file permissions? File permissions means who can read, who can write, who can execute, all those things. And when is it created, when is it accessed, when is it written, all the details, that is file dates. And file owner, so what is the owner group and who are all the owners of the file, everything will be here. And the file size, the size of the file in terms of the bytes, and file data blocks or pointers to the file data blocks. So it means that whenever you are going to have a file, that file will be containing many blocks, and all these logical blocks have to be mapped onto the physical blocks, right? Now let us say a file is containing block number 0, block number 1, block number 2, block number 3 and 4. Now this block may be mapped to block number 500 in this volume or the partition, right? Similarly, this may be mapped to 502, 505, something like this, right? Then entire mapping has to be present in this structure, right? See this, file data blocks or pointers to file data blocks, right? Now a typical file control block. So this is how a typical file control block will look like. Okay, fine.